Hello. All right. So our first questions, or our first section, we were reading what step it was. And then identifying what part of the scientific method it was. So for the first one, this is when she designs the experiment. Kara obtained 2 1-liter jars and placed a frog in each. She inserted a thermometer through a hole in the screen lid of each jar. She then placed each jar inside a larger jar. Kara filled one of the larger jars with ice cubes until the cubes surrounded the smaller jar that held the frog. Kara did not put any of the ice cubes in the other set of jars. We talked about this before. This is when she tests her hypothesis and experiments. This is specifically when she's just setting things up. Our second one, when she reads about hibernation, this is her gathering information and researching so that she can make an educated guess, right? Hypothesis. Our third step, well, actually, that would be the second step. The next question would be asking a question. She's curious and she wants to know how she can make a frog hibernate. That how is a question word, right? Who, what, when, where, how, and why. That's our first step of the scientific method. We always start with a problem or a question. This one, a lot of people got confused. So if you were one of those people that got it confused, please make corrections. You should be writing what I'm writing, please. Kara created a graph of the data to help her determine what had happened and why. Her determining what had happened from the data is her drawing conclusions. Not physically like drawing, but her, you ever play like a card game and they say draw a card? Right? What they mean by that is like collect, right? Collect a card. So we're going to collect conclusions, look at our data and come together with some conclusions. The next one, every 30 minutes, Kara recorded the temperature inside each of the 2 smaller jars. She also recorded the breathing rate of the frog and other observations about the frog's appearance and behavior. Kara noted that in the jar with the ice cubes, the frog began to move more slowly and finally seemed to go to sleep. The frog's rate of breathing became slower too. These changes did not occur in the other jar. When the ice was removed from the first jar, the frog gradually became more active. That is experimenting. So this is when she actually conducts the experiment. That's step number 4, testing the hypothesis. After reading about the topic, Kara made an educated guess. Ding, 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 keyword, right? She guessed that she could make a frog hibernate by making it cold. That's forming a hypothesis, and that's step 3 of the scientific method. Last but not least, she came up with a summary of the results. See, I'm circling keywords that are going to give me the answers. That's reporting results, and that's step 6 of the scientific method. Is there anybody that needs me to repeat any of them? Okay. I will give you a copy of mine, okay, because you were absent. So I'm moving on to the next page. What was Kara's hypothesis? Who can tell me what her hypothesis was? Cody. Perfect. She said, if you make a frog cold, it will hibernate. You could say, if I add ice, because that would definitely identify our IV, right? If I add ice and make it cold, then it would make it hibernate. Yeah. All right. It's about to get really confusing up in here with this graph. This chart. So just pay attention for me. All right, just watch. Just watch. In jar A, I have a thermometer that goes into the smaller jar. I have a frog. I have smaller jars, these smaller jars right here. In jar B, oh, and I also have the larger jars. See how I'm labeling everything? I've got my screened lids, my larger jars. And jar A has no ice in it, right? So that is my control group because it's original, OG. It's not normal to put ice on a frog. If you're freezing frogs, I'm concerned about you as a person. What? We did microwave mice. That is true. The only thing I didn't label was the screen lid. Jar B. I've got the larger jars. I've got my thermometer, the ice, the screen lids, the frogs, the smaller jar. And it is my experimental group because I'm experimenting by adding ice, right? What were some of the things that remained constant or the same between both jars? What were some of the things that remained the same between both jars, Joel?
The screen.
So the screened lids. What else, Brian? The type of frog. What else? Look at the pictures. What else was in both? That's why we wrote them in both. What else was in both, Melissa? The breed of the frog, Kyle.
Same type of thermometer.
Same type of thermometer, right? You don't want me using one of the digital ones I use to take your temperature in the morning and then one that goes under your tongue. That won't be consistent. So I said the thermometer, the type of frog, the size jars, the same lids, the same environment. Well, there's no water in there, right? Do we label water? Do we label water in our picture? So there's no water in the jar. It's just the printing, the shading. What was the one thing that was different between the jars, the variable? What was the one thing that was different between the jars? Somebody at home? Maybe Lucas? What was the one thing that was different between the jars? What was our variable?
The one thing that was different was one was colder and one wasn't.
One was colder and one wasn't, but what did they add to that, Andrew? What did they add to the jar to make it colder?
Ice.
Ice. That was our variable that was different. The whole reason we labeled that jar, that picture, was so that it was easy for us to see what was different. I can promise you, if you're drawing on your paper, like if you draw the experiment out, I'm not talking about like drawing random stuff, but if you draw the experiment out on your paper, it will help you. Just like we took the time to label, right? Even though my labeling was kind of messy. If you take the time to do that, I can guarantee you it'll make a big difference in the way you understand what's happening. How many people visualized this picture when they were reading the experiment on the front? How many people thought it was better when you could see it on paper? Helped you understand what was happening in the experiment better? Good. That's why you're sitting right next to me. We already answered this question together. We're past that. Please stop drawing on yourself and write on your paper instead. Thank you. We already did this part where we label which one is our control group. Let's just reiterate that. First of all, tell me what a control group is. Somebody? Diego? The group that you control to do what? It stays the same. So which jar was my normal or my same? Group A, because it was the OG jar, the one without the ice. Braylon, what was my experimental group? Jar B, why?
You were experimenting the frog temperature, like
Absolutely. I was experimenting with it. I was testing it. I was trying new things. Our independent variable was ice or no ice. So I either added ice or I didn't add ice. If your paper doesn't look like mine, that's going to be a personal problem. We spent all that time labeling, and I see so many papers that don't have this experiment labeled. Remember, I don't go over this for me. I don't do this for me. I really don't. I originally was not going to go over this assignment with you, and I was just going to collect it. Really? But I figured we would benefit because of our unit test coming up, seeing an experimental design all the way through, right? So if we're taking the time from our day to do it, that means that it's important. Means that we should make sure we're doing it. And our dependent variable is if the frog hibernates. So we're actually specifically measuring the breathing rate. What was, we already answered this question, but it said what was our control group, and it was jar A because it has no ice. Now, I want to make sure we have enough time for you guys to work on some of your study islands and answer the remaining questions. All right, I've already done this graph for us. So the way that this graph is organized, I have jar A, that is the orange. That's my original jar, right? That's my control. And then I have jar B, which is my experimental group. I did this separately. You don't have to do this. Remember I said we were going to graph it together? So my temperature is marked with the ones that look like stitches, kind of like a thermometer, right? And my breathing rate is the plain normal line. Let's look at our control group. The orange lines show that I kept the temperature the same the entire time at 22 degrees Celsius. This orange line right here shows the normal breathing rate of the frog. Does everybody understand that? What do we notice about the temperature for our experimental group? What did we do with the temperature for the experimental group? Remember, that's this line.
We changed the temperature?
We changed the temperature to increase it or decrease it. Did we increase or decrease the temperature? Decrease, and then we increased it back again, right? What happened to the frog? What happened to the frog's breathing rates when we decreased the temperature? When I went down in temperature, what happened to the breathing rates, Braylon? It went down. Perfect. What about when I raised the temperature back up? It went back up. So what I want us to look at on the bottom of our paper, where it says jar A. Everybody look at where it says jar A at the bottom of our data table. Mine's already completed, so I gotta get a blank one. I'll just use this. So when it says jar A, my control, what did we notice? What did we notice for jar A? Remember, that's our control. What did we notice? Did we change the temperature? No. And what happened with the breathing, Kyle? Normal. So what I would write is temperature stayed consistent at 22 degrees. Breathing rates were normal. They're all normal. normal, right? That's our control or our comparison. So the temperature stayed the same. Breathing rates were normal. And you see how I used the word comparison? Because we're using this to compare the effect of changing the temperature. I'll give us about a minute. Remember, I'm collecting this and I might actually end up making it a mastery grade instead because I see some people who are making corrections on their papers. What about the second one? What about jar B? Let's reiterate those terms, the words increased, decreased. Tell me in a scientific way what happened. Landry. Okay, so let's talk about the words increase and decrease. So as temperature decreased, what happened to breathing rates? What word would that be, increased or decreased? Decreased. So as temperature decreased, breathing rates decreased. As temperature increased, breathing rates increased. So as temperatures decreased, breathing rates decreased. When temperature increased, breathing rates increased. We're going to focus on the hibernation part in the conclusion, the next step. So as temperature decreased, breathing rates decreased. When temperature increased, breathing rates increased. If you submitted this, if you're at home and you submitted this and something that you submitted wasn't right, you can always resubmit it to me after we've gone over it. Okay? So Landry, I'm coming back to you real quick. Was our hypothesis confirmed or denied? It was confirmed. Our problem was, how does temperature affect breathing rates? And our hypothesis was confirmed because as temperature decreased, breathing rates decreased as well. And our breathing rates decrease when we sleep. Then that doesn't mean we stop breathing, but is anybody sleeping like this and breathing like?
Sometimes.
No, if you're having a nightmare, right?
Like you just wake up out of nowhere.
It's happened before. I want you guys to do part C by yourself. I want you to draw or collect conclusions from the data that we just did, right? The data that we just graphed. I will put the graph back up there. When you're done with part C, I want you to grab an iPad, please.
What is before Derby?
What?
Temperature on Derby on the bottom line.
Say what?
What is before temperature on Derby on the bottom line?
Before, as? Hypothesis confirmed because as temperature decreased, breathing rates decreased. Or you mean jar B?
Yeah.
So where it says jar B, it says as temperature decreased, breathing rates decreased. When temperature increased, breathing rates increased. So I want you guys to come up with conclusions on your own. It says to please provide a biological explanation for her results, meaning use your prior knowledge to explain what happens when things get cold, right? When you are finished with C, I want you to grab an iPad so we can begin working on our study island lessons that are due next week, y'all. Next week.